To review briefly, the correlation coefficient is a value between -1 and +1. The farther we are away from 0, the stronger the association between two variables. Whether it's positive or negative just means those variables change in the same direction or opposite directions. The correlation coefficient is great relative to a scatter plot because it reduces the questions about the strength of the association down to a single numerical value. But something that's very, very important to stress at this point in the conversation is that correlation absolutely never, ever implies causation. It can seem very appealing to make some of those conclusions. If we have a strong association, sometimes we look at variables that are very likely to have some cause and effect relationship, but correlation is never proof of causation. If it was, then Google searches for Batman would cause the number of security guards in Oklahoma to increase. So as more people search for Batman, more security guards would be hired in Oklahoma. These two data sets share a correlation coefficient of 0.848. We would also see a cause and effect relationship between ticket sales for Houston Astro games and instructor salaries across the entire United States. People buying more tickets for Houston Astro games would literally cause instructors in the United States to earn more money. These two data sets share a correlation coefficient of 0.962. That's incredibly strong. We also would have a strong relationship between the distance between Neptune and Uranus versus the CVS stock price. These two data sets share a correlation coefficient of 0.896. And if correlation implied causation, that would mean as these two planets fly around through space, occasionally their orbits getting closer and farther apart, that is literally causing the stock price of a pharmacy to increase or decrease. We refer to these as spurious correlations, and there's a great collection of them at this website that were put together. And what we need to keep in mind throughout this process is that correlations can exist without that implying that a cause and effect relationship exists due to what's referred to as lurking variables. That is, with this analysis that we're doing, we're only considering two variables at a time. We're not considering any of the wide variety of other factors that might be impacting these values to change the way they do. That doesn't mean that looking for correlations is meaningless. Looking for a correlation can be a great first step in the scientific process. First, we need to determine that a correlation exists. That can be relatively easy to do, especially if data is already available. But then further research would have to be done to determine if a cause and effect relationship exists. A phrase that we really want to pay attention to and look out for in the real world, pops up in news reports and things like that a lot, is a statement like, scientists have discovered a link. Between something and something. News outlets tend to pick up on things like this and report things. Oftentimes those links are just correlations. A cause and effect relationship hasn't been proven. There's just some data to suggest that two variables change in the same way or in opposite directions following a sort of pattern. But no other variables have been investigated yet to determine if they're the real cause behind that relationship.